All right, today lesson 27b, day number 2 of exponential functions. Yesterday, our focus was on introducing exponential functions and talking about growth and decay. And today, we go into a little bit more detail on exponential functions. And tomorrow, we will actually finish off, actually not tomorrow, the next day after that, we'll finish off this idea of exponential functions. So let's just go ahead and get started. In Unit 2, our concentration was on linear functions, which are characterized by having a constant rate of change, which we then realized was the slope. In the last lesson, we looked at exponential growth and decay. Today, we will more informally introduce the concept of an exponential function. So consider this function right here. F of x equals 8 times 2 to the x power. Answer the following. So what I want you to do is I want you to evaluate each of the three parts that are in your notes. So in your notes you have f of 2, f of 0, and f of negative 1. I'll give you about a minute to a minute and a half to go ahead and evaluate all three of those. All right, Morgan, f of 2, what did you get? 32. 32. Is that correct? Yes or no? Yes. All right, it is because we have 8 times 2 squared. 2 squared is 4, and 8 times 4 is 32. Max, how about, and we're going to come right back to this in just a second, but when we are evaluating functions, basically what that gives us is this gives us an ordered pair because 2 is representing x, and the value that we got after we evaluated it, that gives us a y value. But we're going to come back to that in just a second. But could you go ahead and write down that ordered pair below f of 2? Because we are going to utilize that in just a second. All right, Max, sorry. Back to f of 0.
F of 0 is 8.
It is 8 because we have 8 times 2 to the 0 power. 2 to the 0 power is 1. And 8 times 1 is 8. That gives us another ordered pair that is 0, 8. And George, f of negative 1.
F of negative 1 equals 4.
It is 4 because we have 8 times 2 to the negative 1 power. 2 to the negative 1 power, remember, is 1/2. And 8 times 1/2 is 4. So we now have a third ordered pair. So what these give us is these three parts that we evaluated. That gives us 3 ordered pairs. So somewhere off to the side in your notes, I want you to create a table like I'm about to do off to the side here. So we're going to create a table that looks like that. Because what we did is we just generated 3 solutions or 3 ordered pairs for that function f of x equals 8 times 2 to the x power. And so my values are x. Normally it's x and y, but sometimes we utilize the function notation instead of y, which is what I'm doing here. And so when x was 2, y or f of x is 32. When x was 0, y or f of x is 8. And when x was negative 1, y or f of x is 4. All right, so we will utilize that table and those values in a couple of minutes, and we're going to use them on part E. All right, so that's part A. Part B. Calculate the average rate of change of f over the interval negative 1 is less than or equal to x, which is less than or equal to 0. So the first thing we need to do is we need to define what we mean by average rate of change. Is this written in your notes, yes or no? No? All right. Yes? I'm talking about the part that's in the rectangle here. Okay. So for the function y equals f of x, the average rate of that f of x changes from x equals a to x equals b is given by this right here. And if that is not in your notes, you may want to write that down. This is how we find the average rate of change. F of b minus f of a over b minus a. Now, whether you realize it or not, what we are finding there is we are finding this. How much the y values have changed over how much the x values have changed. Anybody in here recognize this part right here? I guarantee you, you've done that in one form or another over 500 times since the beginning of the year. Turn to your shoulder partner and talk about what you think that might mean. Once again, this really represents, in some respects, the slope. So, we have this function, f of x equals 8 times 2 to the x power. In order to figure out what we mean by a and b, I've written this down right here. The smaller number of the two is a, and the larger number of the two is going to be b. And we use those. We use b here, and we use a here and here. Okay? But really, we already have done all of this math earlier in part A. So, here we go. We want to find the rate of change, the average rate of change from -1 to 0. So what's A? Between those two numbers, what's A? What's B?
0.
All right, so what we need to do is we need to find f of b minus f of a over b minus a, where once again, a is -1 and b is 0, and we're using the same function that we used in part A. Go ahead and figure that out. All right, so for this problem, remember, a is -1 and b is 0. So we have f of 0 minus f of -1 over 0 minus -1. And all I did here, we said that this was a, so -1 right there, -1 right there. We said that this was b, so 0 replaces b here and here. Now we're utilizing this function right here, the original one that we had for part A, to find these values right here. So f of 0, which you did in part A, and f of -1 you did in part B. Or excuse me, part A once again. It was, I can't remember which part it was. But what was f of 0? What's f of -1?
4.
All right, so we have 8 minus 4 for the numerator, and in the denominator we have 0 minus -1, which of course is +1. And so we know that from this interval right here, the average rate of change is 4. And what we're trying to see here is with linear functions, they all had a constant rate of change. We're trying to see if the rates of change are constant. In other words, if the rates of change are the same. All right. Let's now go to the second part. Notice that I'm now changing the interval. I would like you to find the average rate of change for this interval now. And since I just went through a different one in part B, you should be able to do part C. I'll give you about a minute to find the average rate of change. All right, so for the interval from 0 to 2, that means A is 0 and B is 2. We utilize the average rate of change formula here if we want to think of it that way, and we should end up with 12. Now, part D says, what does comparing what you got in B and C tell you about this function? Well, were the average rate of change, were they the same or were they different? Look. Were they the same or different?
Different.
Let's try that again. Were they the same or different?
Different.
They're different. That means they're not constant. So you need to write something down that makes sense to you. So the rate of change for each is different. In other words, the rates of change are not constant. This means that this function is not linear. Back in Unit 2, we recognized the fact that if the rates of change were constant, if we had a constant rate of change, that ended up giving us a linear function. But if the rates of change are not constant, that means the function that we have is not linear. Okay, so in addition to that, the rates of change went from 4 to 12, so that means the rate of change are increasing. And so what that does for us is that kind of tells us what that graph may look like since the rates of change were increasing. They went from 4 to 12. So now in part A, I had you write down the table of 3 values, the 3 solutions or the 3 order pairs, however you want to think about that, so that we could graph this function. So now for part E, it says to draw a sketch of this function on the axes below. So we're going to have to add some more numbers here at some point. But one of the ordered pairs from part A, from our table, we had f of 2 was 32, so that gave us the ordered pair 2, 32. So let's go ahead and plot 2, 32. So first thing I'm going to do is sort of divide up my axes a little bit so I can be a little more accurate on my graph. So I'm kind of dividing it by 2 and then trying to be a little more accurate here. So 2, 32 would be approximately right there. All right, second order pair from our table from part A. F of 0 was 8, so that gave us another ordered pair 0, 8. So let's plot 0, 8. That would be approximately right there. And I know that because if 32 is right there, 16 is about right there, and so on. We're just drawing a sketch. And then our third ordered pair coming from f of -1 equals 4 would result in the ordered pair -1, 4. And that ordered pair would be approximately right there. If we connect these dots together, we can see that it's curving up. That's because the rates of change were increasing. And so most exponential functions, or many of them, look like that. So go ahead and make your exponential function, the sketch of your graph, look like that. Remember, we knew it was not linear because the rates of change were not the same. We noticed that the rates of change were increasing, so therefore the graph should be increasing from left to right. All right, so let's continue on here. Oh, we need to add one thing to the graph here, sorry. That is the y-intercept. That's where it's crossing the y-axis. And back from when we did linear functions, the y-intercept gives us the initial value. And we'll come back to that again. The y-intercept is the initial value. All right, so now we can move on. Exponential functions are all about multiplication. The basic form of an exponential function is given below. And you have this in your notes, and I know you have some blank spots that you need to fill in here. A general exponential function has the form y equals a times b to the x power. Sometimes instead of y we use f of x. Those are interchangeable. One is just referring to a function. Where a is the y-intercept and b is the base or multiplying factor. Sometimes b is known as the growth factor. Now, if you understand what we're saying here, we can come up with an exponential function very quickly. Once again, this is the y-intercept. This is the multiply number, the number we're multiplying by each time. All right. Since a is the y-intercept, it can be thought of as the initial value, and I kind of hinted at that when we talked about the graph. All right, let's go to the back side. We're on number 2. Consider the function g of x equals 54 times 1/3 to the x power. Yesterday, we saw the rumor problem where the numbers were getting bigger quickly. That was a growth problem. And then we talked about the windmill problem where the person was walking towards the windmill. That function ended up looking something like this one right here. 54 times 1/3 to the x power. Right now, for part A, I would like you to evaluate g of 0. And I'm asking you, what point does this indicate on the graph of G? Go ahead and do part A. All right, turn to your shoulder partner and answer or compare what you have for part A. There are two parts, evaluating G of 0 and talking about what point that indicates on the graph. You have about 45 seconds. G of 0 is 54. Okay, so let's deal with that first. The reason why it's 54 is because 1/3 to the 0 power is 1, and 54 times 1 is 54. All right, continue on.
And it represents the y-intercept or the initial value.
Exactly, perfect. So we get 54 for G of 0, and that indicates 0, 54 on the graph, which happens to be the y-intercept or the initial value. And we need to remember that. That's very important when we wanted to come up with the actual function for an exponential function. All right. We're still talking about the same function here. Let's go to part B. Without the use of your calculator, determine the values of G of 1 and G of 2. I'll give you about a minute to deal with that. For G of 1, that gives us 54 times 1/3 to the first power. 1/3 to the first power is 1/3. 54 times 1/3 is 18. So that gives us an ordered pair, and we've talked about that in full detail throughout this lesson. That gives us another ordered pair. X is 1, G of 1 is 18, therefore that ordered pair is 1, 18. G of 2, that's going to be 54 times 1/3 to the second power. 1/3 to the second power is 1/9, and 54 times 1/9 is 6. That gives us a third ordered pair. So with those three ordered pairs, let's now go to part C and sketch a graph of that function. Here is what your graph should kind of look like. We have three ordered pairs, 0, 54, 1, 18, 2, 6. We do need to put some numbers on both of our x and y axes. And when we plot those, and your numbering doesn't have to look exactly like mine, but your graph should look very, very similar. So that's what the graph of that function should look like. Now, part D. Part D is asking, why is this exponential function always decreasing while the one in exercise 1 is always increasing? I want you to think about that for a second. And I want you to turn to your shoulder partner and see if you can come up with something so that we can then sort of come up with a summary of how we will know whether our graph should be increasing or decreasing without doing anything. Go ahead, turn to your shoulder partner and have a quick discussion. So, if the base is between 0 and 1, or as Sam said, a fraction, but we have to define it a little further, a fraction between 0 and 1, that means we're going to end up with a decreasing function. So let's fill in our little chart here. Y equals a times b to the x power will increase if b is greater than 1, if the base is greater than 1. But if the base is in between 0 and 1, that means it will be decreasing. And if we look back to number 1, b was 2, which is greater than 1. That's why it was increasing. But in number 2, as we can see right here, the base is 1/3, or b is 1/3, which is between 0 and 1. So increasing if b is greater than 1, decreasing if b is in between 0 and 1. All right, let's continue on here. All right, number 3, for each of the following exponential functions, give its y-intercept and tell whether it is increasing or decreasing. Go ahead and do part A, part B, and part C. And then we'll compare those with our shoulder partner. Part A, look like this. Athena, give me the y-intercept first and then whether it's increasing or decreasing.
The y-intercept is 8 and it's decreasing.
And it's decreasing. Good. Why is it decreasing?
Because it's a fraction. Is a fraction.
Let's specify it a little better than that, because technically 8/5 is a fraction, right? But 8/5 wouldn't represent a decreasing function?
Um,
Let's define it a little better than that.
because b is between 0 and
There we go. Yeah, it's a fraction, but it's a fraction between 0 and 1, okay? So the y-intercept is 0, 8. That's the initial value. And because b is in between 0 and 1, it's decreasing. Spencer, part B.
The y-intercept is 125 and is increasing.
Let's state it as an ordered pair, though.
Y-intercept.
Look at part A. Look at what I have for part A for the y-intercept. The y-intercept is always 0, something because it lies on the y-axis, correct? You told me it was 125. Let's state it as an ordered pair.
0, 125.
Okay. Now, increasing or decreasing?
It's increasing
Why?
because b is greater than 1.
Because it's greater than 1. Very good. And then how about part C? Lauren?
it's decreasing and the y-intercept is 0, 56
Very good. And why is it increasing?
because b is greater than
Yeah, notice that this time I did give you b that was a fraction, but it's a fraction greater than 1. So we have to define that a little better than that. All right, we've got one problem left here, and that's number 4. I'm giving you a table, and I'm asking you to come up with the exponential function. Before you do that, once again, this f of x, and I did this, I stated this, and defined it earlier in the lesson today, but this is the y-intercept or the initial value. This, we sometimes call it the multiply factor or the growth factor, or sometimes we just say it's the multiply number. It's the number that we're multiplying by each time. Quickly come up with your exponential function for the values in that table. So we need two things in order to find the exponential function. We need the initial value or the y-intercept. This right here, 0, 10, that is the y-intercept or the initial value. And then we need to look down here to figure out our multiplying factor. Well, down here I can see that we are multiplying by 3 each time. 10 times 3 is 30, 30 times 3 is 90, and so on. That gives us exactly what we need. So the initial value or y-intercept is 0, 10. That gives us the fact that a is equal to 10. And the multiplying factor or multiplying number or growth factor is 3. That gives us the fact that b is equal to 3. And so our function is f of x equals 10 times 3 to the x power. I know in your notes it does use y here. And so based on that fact, you probably have y equals 10 times 3 to the x power. All right. Any questions? All right, we are finished.